Group 13, the boron family group. The elements of this group are going to be the nonmetal boron, the metals aluminum, gallium, indium, thallium, and then we have a man-made metal, which is going to be nononium. Nononium was made in a particle distributor in Japan, which is where it gets its name. The characteristics of nononium aren't known, but it's assumed to have the same characteristics as indium and thallium. The occurrences and uses of these elements, we see boron in borax, we see aluminum in, of course, cans and foils, we see gallium and indium in mirrors, and we see thallium in reflective lenses. The characteristics of the group, the elements will have 3 electrons in their outer shell, with the electron configuration ns2, np1. The typical oxidation state of these elements are going to be a 3+ state. Thallium also typically forms a 1+ state in most cases. And when the metals bind to create salts, they have a 2+ oxidation state. Binary compounds. When forming with oxygen, all of the elements will form 2 elements themselves with 3 oxygen atoms. In the case of boron, it is acidic. In the cases of aluminum, gallium, and indium, they are both acidic or basic, depending on their environment. In the case of thallium, it is only basic. When forming binary compounds with halogens, all of the metals will form with 4 of the halogens themselves, creating a -1 charge on the compound. One exception to that rule will be aluminum, forming with 3 chlorine atoms. And gallium also likes to form with just 2 of the halogen atoms. When forming compounds with nitrogen, only boron and aluminum will react with nitrogen itself. Gallium, indium, and thallium do not react with nitrogen. When forming with hydrides, boron itself will form with 3 hydrogen atoms. With the metals, they will form with 3 hydride atoms. With chalcogens, all of the metals form 2 metal atoms, with 3 of the chalcogens being sulfur, selenium, and thallium. With the case of thallium, only 1 of the chalcogen will bind with 2 metals. Highlights of these groups will be the elements were not all discovered in their pure states. Gallium has such a low melting point that it can melt in our hands. And boron forms hydride atoms, creating a hydrogen bridge between the boron atoms. Thank you.